Hello there, this is Dixon from MathsWiz, where we teach mathematics and mathematical sciences. Welcome for this lesson. This is our second lesson in the series Mathematical Equations. In this lesson, we're going to learn how to determine solutions of basic quadratic equations with one variable. It is important to note the following. Number one, quadratic equations are equations whose highest power of the unknown term is 2. Number two, one variable means that the unknown term is of one type only. Number three, solution of an equation means the numerical value of the unknown term that satisfies the given equation. And this lesson will include three methods of solving quadratic equations with one variable, namely quadratic equation formula, factorization, and completing the square. For us to use quadratic equation formula, we have to determine the following. If ax squared plus bx plus c is equals to 0, then the quadratic equation formula is x is equals to minus b plus or minus square root of b squared minus 4ac, everything we divided by 2a. In our first example, we are going to consider the solution of 2x squared minus 3x plus 1 is equals to 0. Notice that the formula for determining x is equals to x is equals to minus b plus or minus square root of b squared minus 4ac, everything over 2a, if the equation is of the form ax squared plus bx plus c is equals to 0. And in that connection, we therefore learn that our a is equals to 2, our b is equals to minus 3, and our c is equals to 1. Therefore, if we substitute these values in the formula, we get x is equals to minus b plus or minus square root of b squared minus 4ac, everything we divided by is 2 by 2. On simplifying, we have x is equals to 3 plus or minus root of 1, everything over 4. Since the root of 1 has two values, therefore the values of x will also consequently be 2. X is equals to 3 plus 1 over 4, or x is equals to 3 minus 1 over 4. And for the positive value, we get x is equals to 1, and for the negative value, we get x is equals to a half. In our second example, we have 3x squared plus 1, x minus 4 is equals to 0. In here, we learn the following, that our a is equals to 3, our b is equals to 1, and our c is equals to minus 4. Therefore, in the formula, x is equals to minus b plus or minus square root of b squared minus 4ac, everything over 2a. Substituting the values of a, b, and c in the formula, we are going to get our x is equals to minus b plus or minus the square root of b squared minus 4ac, everything over 2a, and 2a is 2 multiplied by 3. Once we simplify this, we're going to get x is equals to minus 1 plus or minus the square root of 49, everything over 6, which can also be written as minus 1 plus or minus the square root of 49 is 7 divided by 6. The positive and negative values of 7 give two values of x, so therefore we have either our x is equals to minus 1 plus 7 all over 6, or x is equals to minus 1 minus 7 over 6. And from the first solution, we have x is equals to 1, and the second solution, we have x is equals to minus 4 all over 3. We now use the method of factorization in solving quadratic equation, and in this case, we first of all require to remind ourselves something. One, if we have x plus 2 into x plus 3, for us to expand this expression, we are going to do the following. We multiply the second bracket followed by the first term here, which would give us x into x plus 3 plus 2 into bracket x plus 3, and this one will give us x squared plus 3x plus 2x plus 6. Combining like terms together, we get x squared plus 5x plus 6. Now you're going to learn that the process of factorization is moving from whatever we have got as our final answer to whatever we had as the initial solution. One thing we have to realize is the following. The coefficient of x is equivalent now to 2x added to 3x. And if you multiply the two coefficients, you get now the value 6. And that is the idea we are going to apply in the process of factorization. Now, the first step in factorization requires us to determine two values, p and q, such that when they are added, they will give us the coefficient of x that is equals to plus 1. And when they are multiplied, they will give us minus 12. For us to determine this, we are going to use the factor method of the product of p and q. And from 12, we are going to determine its multiples. And one of the multiples, we have 1 multiplied by 12. 2, we have 2 multiplied by 6. And the third, we have 3 multiplied by 4. If we take now the first one, since the product is negative, one of the value is negative, the other one is positive. And if we look at the sum, since the sum is positive, it therefore means that the big value is positive, the small value is negative. This is minus 12, but when it is added, we are going to get 11. This is minus 12, but when we add, we are going to get a 4. This one is minus 12, but when we add, we are going to get a 1, meaning that this is the choice of our two numbers. We now rewrite the equation, but in place of x, we put the values we have got for p and q, and we are going to get x squared plus 4x minus 3x minus 12, everything is equals to 0. We would like to group these values into two groups. The first group is the first two numbers. The second group is the second two numbers, including the sign between the third and the second number. Now for each group, we factor out the common value. Now in the first group, we have x squared and 4x. X squared is common. We have x into brackets x plus 4. In a second group, minus 3 is common. We factor it out. So we have minus 3 into brackets x plus 4 is equals to 0. We further realize that the bracket is common. So if we factor the bracket out, we're going to get x plus 4. Here we are left with an x, and here we are left with a 3 is equals to 0. And in this case, we have to make two choices. My first choice will give me my first answer. I'll divide both sides by x plus 4. And if I do so, I'm left with x minus 3 is equals to a 0, which implies to me that x is equals to 3. My second option is now I divide both sides by x minus 3. And on this side, I'm left with x plus 4 is equals to 0, meaning to me that my x is equals to minus 4. Our fourth example of the lesson is 3x squared minus 11x minus 4 is equals to 0. We shall first of all factorize the expression on the left hand side, and in this case we require again two values, p and q, such that when p is added to q, we get minus 11, and p when multiplied by q, we get 3 multiplied by minus 4, and that gives me minus 12. Again, we use minus 12 to determine now the pair of values p and q, and our pairs are as follows. The first pair is 1 and 12. The second pair is 2 and 6. The third pair is 3 and 4. Considering the coefficient of x, we learn that the sum is negative, meaning that the big value is negative, the small value is positive. And if we do so, we have plus 1 and minus 12. And if we add the 2, we get minus 11, meaning that this is directly our choice for p and q. Now we rewrite the equation using the p and q, and we're going to get that 3x squared minus 12x plus x minus 4 is equals to 0. On grouping the four values, we have 3x squared and 12x is grouped together, plus x and minus 4 grouped together. In each of the group, we factor out the common term. In this case, 3x is common, so therefore we have 3x into brackets. We are left with x minus 4. In the second group, 1 is common, so we factor out 1. Hence, we have x minus 4 is equals to 0. The two brackets are common, so we factor them out. So we have x minus 4 into 3x plus 1, and this one is equals to 0. Now I have two choices to make. I'll make the first choice, hence it will mean that my first answer, divide both sides by x minus 4, I'm left with 3x plus 1 is equals to 0, and this one will simply tells me that my x is equals to minus 1 over 3. My second option, I divide both sides by 3x plus 1, and that one will tell me that my x minus 4 is equals to 0, which directly implies to me that my x is equals to 4. We now look at the third method of solving quadratic equation, and this is completing square method. In this case, we are going to be guided by two principles. The principle number one is about the perfect square. We say that a quadratic expression is perfect if it holds the following condition, that is x squared plus ax plus b is equals to x plus k everything squared, whereby k is a numerical value. Number two, if x squared plus ax plus b is a perfect square, then we have a over 2, everything squared must be equals to b. In our question number 5, we are going to use completing square method. And in this case, we are going to be guided by the two principles we have observed at the top there. The first thing is you check if expression is perfect square. And as we have observed at the top, if the expression is perfect square, then it will mean that the value of a is 7. We divide it by 2. Everything squared should be equals to 3, and for this case it is not. Hence we say that the expression is not perfect square. Now that the value of 3 doesn't make our expression to be perfect, we eliminate it from the left hand side, we take it to the right hand side. That is, you eliminate the constant term, and if you do so, our expression becomes x squared plus 7x is equals to minus 3. Note, for perfect square, we have x squared plus ax plus b. And in our expression, the term for b is missing. Hence, we determine the value for b. And we are going to say that our value for b is therefore equals to 7 over 2, everything squared. Now, in our step number 3 is add value of b on both sides. And if we do so, we are going to have x squared plus 7x plus 7 over 2, everything squared, is equals to minus 3 plus 7 over 2, everything squared. So the equation we have formed, we factorize the left hand side and simplify the right hand side. We're going to get x plus 7 over 2, so everything squared. And the right hand side simplifies simply to 37 over 4. Take square roots on both sides, and we get x plus 7 over 2. Right hand side, we're going to get root of 37 over 2, positive and negative. Based on the two values that appear on the right hand side, we can make two options of x. That is, we have either x plus 7 over 2 is equals to plus root of 37 over 2, or x plus 7 over 2 is equals to minus root 37 over 2, which simplifies to x is equals to plus root 37 over 2 minus 7 over 2, which is equals to minus 0.4586, while x is equals to minus root 37 over 2 minus 7 over 2, which is the same as minus 6.5414. In question number 6, we are going to use completing square method. And for completing square method, we earlier said that the expression should first of all be of the form x squared plus ax plus b is equals to 0. Now we learned that the coefficient of x squared is equals to 4, and we want to reduce this to 1. So we divide all members on the left hand side by 4, and if we do so, we are going to get x squared plus 3x minus 9 over 4. Everything is equals to 0. The next thing, we have just learned that if this expression is a perfect square, then a over 2, everything squared, must be equals to b. We check that, and we have 3 over 2, everything squared, is not equals to minus 9 over 4, meaning that our expression on the left hand side is non-perfect. So what do? We move the term that is making it to be non-perfect, that is the constant term, and we get x squared plus 3x is equals to 9 over 4. At this point, we add a value for b on both the right and left hand side, so therefore we have x squared plus 3x plus 3 over 2 everything squared is equals to 9 over 4 plus 3 over 2 everything squared. At this step, we factorize the left hand side and simplify the right hand side, and we are going to get x plus 3 over 2 everything squared is equals to, if we simplify the right hand side, we are going to get simply 9 over 2. In the next step, we take square roots on both sides, and if we take square root on this side, we are going to get x plus 3 over 2 is equals to, this is 3 over plus or minus root 2. Because of the two values that appear on the right hand side, that is the positive and negative values, so we have two choices for x, meaning that our x is either x plus 3 over 2 is equals to plus 3 over root 2, or x plus 3 over 2 is equals to minus 3 over root of 2. If we collect the like terms together, the first choice, we have either x is equals to minus 3 over 2 plus 3 over root 2, and that one is equals to 0.6213, while x is equals to minus 3 over 2 minus 3 over root 2 is equals to minus 3.6213. This is Dixon again from MathWiz. We hope you have enjoyed our today's lesson. Remember to subscribe to our channel and also give this video a thumbs up. Thank you for your watching.